Good afternoon. Hello. Can you hear me? Hello. Can people hear me?
Yes, I can hear you, sir.
Okay. Let us start. I have shared in the group what we are going to look at today. I can also share my screen here. Okay, so we are still in artificial intelligence. We are still looking how these AI systems are built, on which grounds the AI systems are running. So the other time we introduced ourselves with some of the principles and the theories that they use. Today we are going to see another theory. Just a minute, someone here is busy calling me. I don't know what he's saying. Hello? Hello? Okay. So we are going to look at the 8 puzzle. Can everybody see my screen very well?
Yes, sir.
So
Yes, we can.
the topic is said to be the 8 puzzle. Now this one, many of you have played this puzzle before. But little did you know that you'll meet it in the AI lessons. You see this picture which you are seeing on the screen here. Now this one, it has 8 numbers. 1, 2, 3, 4, 5, 6, 7, and 8. But there's an empty space here. Now this is a 3 by 3 matrix. It has 3 rows and 3 columns. So 3 by 3 it forms 9. But the 9th part is empty. So we are going to use that 9th part to move those numbers until when they form what exactly we need. For example, if someone told you to make 4, 7, if this puzzle was beginning with 1, 2, 3, 4, 5, 6, 7, 8, okay? Then someone tells you to change it. There are some students who are calling me now and again. Let me first speak. Okay. So if someone told you to arrange these numbers in the form of 4, 7, 2, 8, 6, 1, 3, 5. So the issue is, how are you going to use this empty space here and move these numbers? So now as you are here, there's a possibility that you move down, then you move like this. Either you have a possibility of moving this one down, or you begin by moving this 5 down, but you have to start. When you move this one down, then you have a possibility of moving the 6 this side, a 2 down. If you move this 5 here, you have a possibility of bringing a 3 here or the 6 here. But at the end of the day, we need to make a certain arrangement, which is not easy. So this is called the 8 puzzle. And the issue is what it is and why is it necessary in artificial intelligence. So the 8 puzzle is a classic problem in artificial intelligence and puzzle solving research. So when we say it is a classic problem, as you can see, if I told you to rearrange those numbers, it is not easy. It is a real problem. It requires you to think a lot in order for you to get these numbers. So even these robots which are created, they think. They are given a puzzle. When you go to ChatGPT, you give it a puzzle, and then it is going to look in various databases. What do I bring first? Okay. Maybe it has an option to move 1 down. It has an option to bring 5 from the side. But the issue is, what option is it going to choose? Okay. If you went to ChatGPT and you tell me more about NRM government in Uganda, it has so many answers it can give you about NRM government. But the question is, what answer is it going to give you first? Now, that's a problem. When some people are given the answer, they are contented with that. But when you go ahead and tell ChatGPT, I'm not convinced with this answer. Can you give me another answer? Just go take another option. Okay? So eventually, it will reach what you want. But the problem now with the students, when they go, it gives the first answer, they copy, they paste, they throw there. When they send to a lecturer, he says it is wrong. We say, but it was given by ChatGPT. But ChatGPT also has options. It has best answers and it has worst answers, depending on how you interact with it. So it consists of a 3x3 grid with 8 numbered tiles and 1 empty space, as you see. The objective is to move the tiles into a goal configuration by sliding them into the empty space. So we have a goal state, we have a present state, and a goal state. So if this is the present state, okay, and our goal state is to have maybe 852 up. Our goal state is to have 852 up and to have 3, 4, 1 here, and maybe 7 and 2 here. So we have what we have, the present state, presently what is there, okay? But actually, what do you want to achieve after you have moved these tiles? That is called the goal state. So it is an example of a state space search problem, and can be solved using AI search techniques. So such techniques are the ones which AI uses. ChatGPT, those robots, they always look for the best solution. They have more alternatives, but which is the best? Let us go into details to understand it very well. So problem state and problem space. So when you look at the initial state here, okay, understand these words very well. We have what we call the initial state, then we have the goal state, and then we have the state space. So let's look at the initial state here. Now, when we have the initial state here, we have what we call the state space. Now, this one gives us a number of options which we can take. Now, when the state space is in the middle here, okay, when it is in the middle here, and we need our goal state to be like this. Yes, the numbers are 1, 2, 3, 8, 4, 7, 6, 5. That is the initial state. But we want to rearrange these numbers to have 2, 8, 1, 4, 3, 7, 6, 5. This is our goal state. So many students are calling me, I don't know why. Okay, because I'm using the phone of my internet, and when people call, it will end up cutting me off. Hope you can still hear me, people. Am I still on?
Yes, sir. You can hear.
Okay, so we're having a goal state and initial state. Now, when you look at the initial state here, when the state space is in the middle, it means you have 4 options. You have the option of moving this 2 here. You have the option of moving this 6 here. You have the option of moving this 8 here. And you have the option of moving. So when it is in the middle, when the state space is in the middle, you have 4 options. Okay? But when it is on the side like this one, you see here, this side, you have 3 options. You can move the 2, you can move the 4, you can move the 7. You have 3 options. But when the goal state is at the edge, in the corner, like the first picture which we had, when the space is in the corner, here you have only 2 options you can move. Okay, so the number of options you can take depends on the state space, the position of the state space. So the maximum options you can have here are 4. The maximum you can have there are 4. And the minimum you can have there are 2. Okay, so initial state, that is the starting arrangement of the tiles. The starting arrangement, we call it the initial state. Okay, when you go to ChatGPT, there is a state you find it before you start disorganizing it, that initial state. Then the goal state is the desired arrangement of the tiles. How do you want these tiles to be arranged? That is a goal state. What do you want to achieve? When you go to AI, what do you want to achieve? When you go to ChatGPT, what do you want to achieve? Okay. Yes, you have your initial state, but there's something which you need to achieve. And you, the person using this AI, you have all the options in order to achieve the best out of it, because you're looking for the best out of it. So state space, the set of all possible test configuration that can be reached by legal moves. Then the operator, those are the possible moves, which include the shifting a tile. So you can shift a tile to the left, to the right, up or down into the empty space. Okay, we'll go to another slide here. We look at it. We have what we call moves and preconditions. So each tile can move if there is an adjacent empty space. As you can see, the first one, we have an empty space. So it means this tile can move, this tile can move. When you come to this, the same thing. When you come to this, the same thing. So legal moves depend on the position of the empty space. If the empty space is in the corner, only two moves are possible. That one I have already said. If the empty space is on the edge, but not in the corner, three moves are possible. That one also I have already said. If the empty space is in the center, four moves are possible. Okay? I know these terms look to be difficult, but they will come clearer with time. Goal condition. So the puzzle is solved when the tiles are arranged in the correct order. So if that is your goal condition, and it is 1, 2, 3, 4, 5, 6, if someone gave you these tiles here, this tile is in number 1 here, okay? You see they are not in order. And the person says, put them in order. I want them as in 1, 2, 3, 4, 5, 6, 7, 8. Okay? So that is the goal state. Where do you begin from? Where you begin from depends on where the empty space is. And some of you play chess. You play chess, and is it maybe Rodo not so much, but it's Mweso. I think that is the idea, especially chess. You have to be very careful. If I move this, if I take this move, are they not going to eat me? If I take this move, will I win? And you have seen people, he takes a wrong move, they eat him all together, and then the game is finished. Just because of a slight mistake you have made. So even here, should I take a 6 down? Should I take 8 to the right? Should I take a 7 down? Should I bring a 6 up? Should I bring a 4? Okay. So these are all the theories behind the AI systems which you are seeing, which are being created. Okay. What lessons do we learn from the 8 puzzle? Yes, the 8 puzzle is just chipped into AI. 8 puzzle basically is not AI, but there's some knowledge which you are chipping into AI. Okay? So we want to look at how it applies into AI. And we are going to look at a basic production system for solving the problem. Now, when you talk of production system, just think of a company like New Vision. In New Vision, for you finally, you're going to see the newspaper. But there's a system which it goes through. These papers go from this place, then they send it to this place, then they send it to this place, then finally it reaches where they wrap it and they tie it off in bundles. That's what we call a production system. Production system has a starting point and has an ending point. This is what we see in the 8 puzzle. In the 8 puzzle, when we are here, we have a starting point. When we want to organize these numbers to look like this, we have a starting point where we need to start. Okay, and then the process goes on until finally we get what we need. So always we have the initial state, and then we do all the movements, the possible moves, until when we have the goal state which is expected. So a production system consists of global databases. Global database. Now, when you talk of global database, what do you mean? Global database, you people have said databases, right? What is a database? Who knows what a database is?
A database is a collection of related data structured. Greetings, Professor.
Greetings to you. You said related what? Collection of what?
Related data, which is structured.
Okay. In simple terms, we can say database, that is where data is stored, right? Now, that data, before you disorganize it, it has a current state, okay? And that is what we call a global database. When you go to AI, the data is there seated. If you do data mining and warehousing, you see that AI has a lot of databases where it is collecting this information from. It is connected to so many databases all over the world. So many, connected to so many. But that data it's in its current state, it is settled there. Okay? It is settled there until when you manipulate it. When you manipulate it, then it is going to start forming sentences. That is why sometimes when you go to ChatGPT, it's going to tell you, I'm thinking. I have taken 5 seconds to think of this. Okay? It is gathering, it is pulling this data from its current state where it is right now, so that it can get something out of it. So the global databases, that is the current state of the puzzle, current data is seated there, okay? Is waiting for manipulation. Then we have operators, production rules. Operators. Operators, we said these are the movements. Remember here when we talked of operators, where do you talk of the term? Okay, operators. These are the possible movements, which include the shifting from the left to the right, down, and so on. Okay? Now, when we come into our production system, we look at the production rules. What are you supposed to follow? So it defines how states transition through legal moves. How is this data supposed to move from this place to such a place? Okay? Yes, you have found that data in its current state, resting, keeping quiet. And for you through AI, you are trickling this database to get out some data. The question is, how does it do it? How does this data move? That is a production rule. So when you are designing an AI system, you should be mindful of the movements your data is going to take, the movement your code is going to take. If a variable is within this function, how is it going to move from this function to another function, especially if it's not a global variable? Then the control strategy determines the order in which states are explored. Now, remember here we talked of the order. For example, here we have 4 orders. You can take this, you can take this, you can take this, you can take this. Here you have 3. So when we talk of the control strategy, what movement are you going to take? Okay. Even in organizations, there are some control measures. When you come to the university, your goals, your initial state, you're a fresher, but your goal is to go with a degree. Yes. So how do you go about it? So the issue is you have to attend the lectures, you have to do coursework, you have to do the exams. When you pass and you don't get a retake, then you go to the next semester, you follow the same things. When you pass, you don't get a retake. So these are control strategies. They determine the order in which states are explored. Then we have the rule preconditions. Rule preconditions. Sometimes you need to put some conditions like, yes, the rule is you will study. The rule is in order to go to another semester, you have to sit the exams and pass. Okay? But you can even put a condition and say, on condition that you don't get a retake. So you can move to the next semester after you have started the exams, but on the condition that you don't get a retake. So rule preconditions specifies conditions under which moves can be made. And we have seen these conditions here. We have seen these conditions that when you are here, you can either have these two, you can move you cannot jump a tile from here and take it to 1. Okay? Even here, we have seen the rules. Even here, we have the 4 rules. Then termination condition. The search stops when the goal state is reached. Of course, when you reach your final destination, you can say, I have ended the journey. You don't continue with the journey. Is it not? Yes? Are we still there?
We are
Sir,
there.
Yes, sir, we are there.
Okay, if you are still there, then that is good. Are the things becoming easier or terrible?
So,
Confusing.
so we're following slowly.
Yeah. Yeah.
I have heard a voice who says, confusing. What is
Yes.
confusing?
The AI, but I'll get to
The what?
the puzzle thing, but I'll get it with time.
The puzzle thing. Have you ever played chess?
No, sir.
Have you ever played hide and seek?
Yes.
But Peru did not chess.
Yeah?
Yes, I know, but I've never played it.
You have ever played hide and seek?
Yes, sir.
You know that game when they cover your eyes and then people run and they hide, okay? Then
Yes.
after when they open your eyes, you are supposed to look for them. So you look at that situation, that is a puzzle now. The issue is which direction do you take? Because you don't know where they have gone. You see? But you know, if I go up, I can get them. If I go in front, I can get them. If I go to left, if I turn, I can get them. But now the question is, you have also all those possible routes. The issue is, which route is the best one you can take? Okay? Are we together?
Yes, sir. Yes, sir.
So when we look at AI has a lot of alternatives. Remember, back into our mind, we are creating a machine that can reason like a human being. Human beings, God has created us in such a way that we have options. You have an option to sin and you have an option not to sin. You have an option to take beer. You have an option not to take beer. Okay? God has given us that freedom. On Sunday, you're free to go to church, or you're free to even remain in your bed, or you are free to go to a traditional shrine. God is not going to stop you. So even we are saying also the AI, it has that freedom. It has a number of choices to take, like this 8 puzzle. At this stage, it has 4 options it can take. At this stage, it has 3 options that can take. At this stage, it has 2 options. But either way, it has to take an option. Okay? Have you ever seen people who are drunk and you ask them why they are drunk and they say, because they bought for us a lot of beer. But they bought beer, they never told you to drink all of it and finish it. Okay? You had the choice to take 1 bottle or 2 and you go home. No one told you that you must take the entire crate and you finish it. Okay? So God has created human beings with options. Okay? This is what we are seeing from the 8 puzzle. We have options to do things. Okay? We have directions to take. You could have chosen to go to Makerere, but you chose to come to Nkumba. You would have chosen to go to Nkozi, but you chose to come to Nkumba to do your studies. Okay? So the issue here, the AI system which you are going to create, which you want to create, has to be like a human being who has options, but he reasons and says, whereas I have this option, let me take this option. Okay? So that is the kind of machine we want you to design. That's the kind of robot we want you to design. We don't want a robot which is just a switch, ta, 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 ta. No, we want a robot which can reason. That's why we are saying artificial intelligence is all about creating machines which can reason more so exactly like human beings. Okay? Because human beings have options. Like in the puzzle we have seen, they have options. Okay? And then here we have what we call termination of the condition. At the end of it all, whatever choice you have taken is going to have an end. But this end, the search stops when the goal state is reached. So your goal state is to get a degree. Okay? You have finished senior 6. You want a degree in computer science. Now you have the option to go to Nkomba. You have option to go outside of Uganda. You have the option to go to Makerere. You have option to go to UCU. Okay? So you have as many options as there are universities in the world, or as universities in the country. Universities in the country. Every university is an option to you. But if I'm to ask you, why did you choose Nkumba? If I'm to ask you, why didn't you go to UK to get that qualification? Why didn't you go to America? Definitely, you're going to give me the reasons why. And that is what we are looking at. This AI machine. Can it reason the way the student is reasoning? Or for it is just going to say, computer science, Makerere. Computer science, Nkumba. You ask it a reason, it has no, because for it is programmed. When you say computer science, it says computer science is done at Makerere. So because Makerere is the first nearby option, computer science, what comes first is Makerere. It says Makerere. It does it because for it, it is just following an order of sequence of programs. So the moment it reaches Makerere, tells you Makerere. But a human being can say computer science, Makerere, then it's okay, I have had Makerere. Another one, Chambogo, I have had Chambogo, another one. Then you start saying, okay, Makerere, how much fees are they paying? Makerere are paying these fees. Okay, Nkumba, how much fees are they? Which one is near my home? Which, for you go a lot of use rigorous reasoning. Okay, we shall see techniques of reasoning. We have reasoning techniques ahead. We shall see them. Okay, so for you, a human being, you go through rigorous reasoning. So we are saying even this AI machine we are creating, this robot, should go through this rigorous reasoning. But can it? That is the question. Can it go through this rigorous reasoning? At the end of the day, it gives us the best option, okay, which is the goal state. That is our question now. Any compliments, any question, anyone want to explain it better than me? Or now things are clear, we move. Yes? We continue? Or people are getting scared?
We continue, sir.
We continue.
Okay. So let's go to another slide. Search strategies for solving the 8 puzzle. So several AI search strategies can be applied to solve the 8 puzzle. We have the unified and we have the informed search strategies. Uninformed search strategies and informed search strategies. We have uninformed and informed. We have what we call the breathe first search, explores all the possible moves at each depth before proceeding further. Breathe first. Why do we say breathe first? Because you cannot breathe continuously. You breathe in, then you breathe out. You breathe in, then you breathe out. So it explores. Now, as you breathe in, you are thinking of an option. By the time you breathe out, you have thought of another option. So explores all possible moves at each depth before proceeding further. This is, just look at ourselves, the human beings. Those people who don't take time to think, okay? I can use the Luganda word, bebatomera. Those people who don't take time to think, bebatomera, okay? That is why sometimes the girls, they tell us, oh, Papa, give me time, okay? Why are you in the rush? Okay? So she's taking time, a breath in, a breath out, a breath in, a breath out. In the process, she wants to make sure she doesn't make any mistake by falling in love with you, okay? So explores all the possible moves at each depth before proceeding further. But the question is, can a robot do that? Because we human beings, yes, we can do it, but can we create a robot which can also do that? It can take a first breath, a second breath, okay? Although some people just rush, okay? So depth first explores one branch deeply before backtracking. Depth first. There's that depth breathe. Some of you have gone to the hospital and the doctor tells you, do a deep breathe in. So it means pull the air for about 5 seconds. Don't breathe in and out, but a depth breathe. So there's some point somewhere where you say, oh, I think let me first study this. I think let me critically look at this. Okay? You take time and say, let me understand this. That depth first search explores one branch deeply before backtracking. So before I go into other things, let me first understand this. There's a saying which says, if you are to dig a hole, you dig one but deep. Instead of digging a small one here, a small one there, a small one. They say you dig one hole, but when it is deep, okay? So understand that thing fully. Now the question is, can a robot take time to understand one thing before it gives another one? That is the question. Okay. Then uniform cost search. Uniform cost search. It expands the lowest cost node first. Sometimes some of us, when we go to town to buy things, we move around shops, from shop to shop, shop to shop. What are we looking for? The lowest cost. You want to buy a gin. You go to the first shop, you ask the price. Then you go to a second shop, also you ask the price. You go to the third shop, what are you looking for? The lowest. Okay? Expands the lowest cost node first. So we always look for the lowest. We don't want to spend a lot. We don't want to spend much time on it. Then the informed search strategy. The informed, we have what we call greedy-based first search. Greedy. The word greedy, to be greedy. Greedy. What appears first, you take. Some men, the first girl, you say, girl, immediately you say, I'm going to marry that one. But you don't know that the other girls are still coming. Maybe the 20th girl is the one whom you are supposed to marry. So you say, girl, you say, I'm going to marry that one. Greedy, what comes first? What is closer to you? Expands the node that appears closest to the goal. If you come back to our goal here, okay? We have which node is closest to the goal, okay? That is what some of you are going to do in your chess. Some people go greedily in chess and they are beaten. because for him it is after. He looks at the king and says he rushes to take this king, and you forget that by taking that king, they can finish up your game. For your focus is because the king is near you here. Has anyone ever played chess online? I'm not a chess player, but I hear those things, king and so on. Horse. Any chess player online? Anyone who has ever played chess here?
Yes, sir. I've ever played chess.
Can you explain to us how it works? Because I don't know. I just see things, but I don't know. Can you explain us how chess works?
Okay, in chess we have different, but let me call them buttons. Like we have the king, the queen, bishop.
Yeah, you
We
even have
have
a
the
bishop.
rook, and yes, sir.
Mm-hmm.
They are all there. So every unit, it has what we call the basic key movements. Like for example, a knight can move in something like let me call it northeast and northwest, that position on the
An
northeast
L
and
form.
something like that. So whenever you want to move your whatever, either a knight or any unit, you have to first calculate what am I aiming at.
So that is the goal state. Eh?
Yes, sir.
Yeah, you are now, Tractor, you are talking of the initial state. I'm here, but what am I aiming at? That is my goal. What goal am I? Okay, continue. You have
Sir,
ended there.
I don't have much information about chess, but the main point is winning. You have to make sure that you conquer the enemy's units. You can conquer the knight, the queen, but
And what
you
are
mean
some
by
of the
chess?
tips? What are some of the tips you can use now you are in the game playing? What tips can you give us that if you do this, you can easily make a mistake and they win you, but when you do this, chances are high for you to win.
Okay. In chess, we have a unit which is called the rook. That rook can move in what to call, it's like a X format. That rook can move in the X format. So you have to make sure that you protect your king and queen so that they are not whatever, they are not captured. The moment they are captured, that can result into a checkmate, which will lead to the ending of the game. So you have to first protect your king and queen, then you can juggle around, capture the enemy's units. Once you're done with all the whatever, once you're done with all the enemy's units, you can win. Something like that. But very difficult.
As you see, it is also a puzzle problem there, solving a problem now. Eh? So what I know, you cannot play chess unless you are good at reasoning. Is it? And people say that
I
some
can
people.
chip in.
Yes, please. Yes, please.
Just to continue on what he was been saying. He said you have the king, you have the queen, we have the rook, the bishop, the knights, and the pawns. So the pawns are the foot soldiers. They move one step at a time. Then we have the bishop. The bishop just moves diagonally. And then we have the knight, which is like the horse, which moves in the L form. Then we have the king. However much the king is the king, but the king is a bit powerless because he just moves only one step at a time. But the queen holds more power than the king. So what you have to do when you're playing is to ensure that you protect your queen most, because the queen can move all other moves. Like a queen can go up, down, diagonal, except the L format, but he can take on all moves. So she's the powerful one. And if you have the queen protected with one of your best pieces, my best piece is the knight, which moves in the L form because it comes unconditionally, unsuspectingly. So with that, and it even jumps other pieces. So if you have the knight, combine it with the queen, then you have your game secured in some way. So those are the two pieces that can work best. Yeah.
Actually, for me, when you are talking, I had something you saying protecting the queen is the most powerful. Could it be why many they don't care about men in the family, but they protect very much the women?
It could be also.
Because the women can move left, right, because you said the queen can move anywhere. And if it is dangerous because the queen can be eaten anywhere, and then the family runs into trouble.
Exactly.
So I get now the logic why we should protect our women. We don't allow them to move anyhow, but the man can move anyhow. Girls, have you heard why we should protect you? Okay, we proceed. The greedy, we have seen the greedy search expands node. Now, what they have explained us in chess there, I have seen, in case you might be greedy to eat the maybe the queen or I don't know the bishop, whether they also hit the bishop, also the queen, but you may end up, or you may be greedy to eat that foot soldier, and they end up when they have eaten your queen and the game is gone. Is it when they eat the queen, the game is finished?
Not really. The game is only finished if your king can't move. So it's called a checkmate. If all the moves around your king, you can't move because you will be eaten, then that's a checkmate and you're out. A checkmate can be achieved even without eating you at some point.
What I appreciate here is reasoning. We shall see, we have a topic on reasoning, techniques of reasoning. So what I see here is reasoning. And that is where our center for this course unit is, artificial intelligence, creating machines that can reason like human beings. Now, if a robot can play chess, can robots play chess? Have you ever
Yes,
seen a
they
robot?
can.
Yes, they can, right?
Yes,
If a
they
robot
can.
now my question is, if a robot can play chess and it reasons, don't you think we are about to create machines which are even going to reason far better than we human beings? Because as you see, there's a intensive reasoning there. Then we have another, what's called a search algorithm. Search algorithm uses both path cost and estimated cost to the goal. Now, both path cost and estimated cost. Now, path cost, what do you mean? You can say, I'm going to Kampala. I'm in Entebbe, I'm going to Kampala. And you can think that the main path to Kampala is the Entebbe road or whatsoever. But estimated cost, you may also think that, okay, as much as that is the main path, but I can also take this direction, okay? So an algorithm, you can take the main path or you can estimate something else and choose to take that. And this is very common in AI systems, especially ChatGPT. Sometimes it is going to give you straightforward answers, but sometimes it is going to do estimates of answers it's going to give you. Okay? So, but in the process, you can determine the best move you can take. You can say, oh, if I look at this junction, which I thought of going this way, I think that one, it will take me longer time. Or you can say, if I take the main road to Kampala, there could be a lot of traffic jam. So let me know, although the main path is easier, but because of traffic jam, let me take another route, which is longer, but with no traffic jam then. So in that process of negotiation, you get what we call the best move, okay? We continue to another one. That is the heuristic functions. We heard about heuristic functions here. So let us see what heuristic functions are. So heuristic functions for the H puzzle. What do you mean by the word heuristic? If someone said that word, what does it mean in English? Who knows what it means? Yes? Heuristic, what does it mean? Is it a new term in English? Okay, who can Google it? You Google it. Anyone who has Googled it?
It means enabling someone to discover or learn something for themselves.
Enabling someone to do what?
To discover or learn something by themselves. In computing, they say proceeding to a solution by trial and error or by rules that are only loosely defined.
So I think that is clear. It is you let someone to find out by themselves. That is what the new curriculum is doing. It's telling the teachers, don't give these students notes. Just guide them. Guide them to find out the notes by themselves. Instead, gone are the days when the teachers used to come with the textbooks in class and they start teaching. And even university, that's where we are heading to. As you people, the old curriculum, we are getting rid of you. Okay? So even now, universities, they are starting telling us to stop giving you notes. Actually, we are not even supposed to give you, but because you are brought up in the old curriculum or the new curriculum, okay? Let people find by themselves, okay? So as you see, these are common things which are in AI. But now the surrealistic has what we call the misplaced tile. Surrealistic, the misplaced tile. So counts the number of tiles that are in the wrong position. So sometimes people are going to search from the wrong place. People are going to search for the right answers, but from the wrong place. Okay? And these are called the misplaced tiles. Okay? So those possibilities are there. You are searching for the right thing, but in the wrong place. Then we have the Manhattan distance. Now this one reminds me of the Manhattan Hotel. There's a hotel there. Is it in Cavalry? Manhattan Hotel. So Manhattan heuristic, it computes the sum of the distances each tile is from its correct position. So sometimes you need to calculate the distance. If you want to achieve something, how long is it going to take you? Okay? How long will it take you to achieve it? So as to get the best route, you need to have some, that is what we call Manhattan, computes the sum of the distance. Each tile is from the correct position. Okay? If you look at our numbers up here, our numbers up there, if we want this 2 to be here, so we look at the distance. Then we say, should we take this direction to get this 2 so that this 2 moves like this? Should we bring it just down like this so that it moves like this? Or should we bring it here, then here, then here? Or should we put here? So you calculate the distance. Okay? Then we have the linear. Just a minute, someone is calling me. Okay, I'm back. The linear. Someone's put a question. I can assist you, or you can assist on what I don't know now.
This was
Maybe.
back then about chess.
Okay. So linear, we have linear conflict. Linear now comes from the line. You know, lines do orderly things. So lines do orderly things. So that's where the linear comes from. Many of you did linear programming. So a more refined version of Manhattan distance accounting for conflicts. So here, linear, you go step by step. You go to court, they ask you, how did the things start? A girl says, I was raped. So when you say I was raped, then the judge goes step by step. Where did they find you to rape you? Then you say, as I was chatting on WhatsApp, he told me I guy meet him. Then I went. So then they go step by step. They look at every statement, every step what you did. Okay, that is linear. I want to finish these slides today. Implementation consideration. So representing the puzzle state as a 2D list or a 1D array. Implementing, those are not so much important. I want to rush to get to applications. Yeah, that's what I wanted to get to. So yes, we have been dying to understand the 8 puzzle. Okay. But the question is, how does it help us in AI? What is the application of it in AI? Why even wasting time to study 8 puzzle in AI? So understanding problem solving and such strategies in AI, basis for solving larger combinational puzzles, like the 15 puzzle used in AI and robotics for pathfinding problems. I have already told you the ChatGPT. When you ask it a question, it has a lot of databases it connects to. So these are paths. Which path does it take first? Which answer does it give you first? Does it give you the answer which is nearby, or it looks for a better answer? Okay. So these are the applications. Okay. So the 8 puzzle is a fundamental problem in artificial intelligence and provides insights into such algorithms and problem-solving techniques. By applying different search strategies and heuristic functions, AI systems can effectively solve complex puzzles and real-world problems. We have something to discuss there. Can someone read for us that discussion element?
You are working on a software that assists students in learning problem solving through the 8 puzzle. How would you implement heuristic-based search methods to enhance the learning process? Suggest ways to optimize the software's performance when solving complex configurations of the puzzle.
Okay. Someone, your background is on which had noise. So you are working on a software that assists students in learning problem solving through the 8 puzzle. How do you implement heuristic-based search methods, those which you have seen above, to enhance the learning process? Okay. Such a question. Suggest ways to optimize the software's performance when solving complex configurations. Online, do you have any distance students online? Do you have distance students online? Any distance?
Yes, I'm here.
One only? The rest you are day students. I can see you are.
I'm also around.
Okay. Now, who is the class coordinator for the day class?
That's
Day
me,
class.
sir.
Sorry, who's that one?
My name is Gadet.
The date.
Yes.
Okay. How many are you in your class?
We're more than 10, sir.
You are more than 10.
More than 15, actually, I think so.
Is it your class or your guessing? Because now you're about to tell me more than 100.
We have our group, and based on the number here, it's more than 15.
Okay, I want to subdivide you into groups.
We've actually done that already. We're in different groups, like 4. One,
Oh, sorry, we made 4 groups. Yes, actually, I was going to say 4
yes,
groups. Okay, so
yes,
in the 4 groups which were created, okay,
yes.
each group will have to search on how ChatGPT was created. You know ChatGPT?
Good. Yes.
Yeah, we want to know what is behind ChatGPT and how does it do its things. How does it tell correct answers? If at all it tells correct answers, how does it know those correct answers? Okay?
Okay.
Are we together? If you tell ChatGPT to tell me more about Nkumba University, immediately it starts telling you. How does it get to know? Okay? What is the logic behind it? What is the power behind ChatGPT? And how does it work? So that is something I want each group must research on it and it should have that discussion. I want you to understand really what is behind ChatGPT. And after understanding what is behind ChatGPT, you as a student of artificial intelligence, can you program something like that? Do you know the steps you can go through to program it? Okay. Does it make
Okay,
sense?
sir. Yes, yes.
Hope everybody has understood what I mean. Our focus as a case study, we are focusing on ChatGPT. We want to understand. And don't go to ChatGPT to ask it how were you created. Hope you get what I mean. So let us take, if we are to benefit from this, let us try to do a thorough research on how that guy whoever created ChatGPT, you go and become that guy who created it. What was he thinking? What was he thinking when he was creating it? Okay. And when he created, what did he put behind it that is able to tell those answers? Okay.
Yes, Master, my network was breaking. Could you come again with the question?
Yeah, your friends have got the question. You ask them. Our focus is on ChatGPT. You become the person who created it and you think like him. What exactly did he think and put it behind? Such that when you ask it a question, tell me about Nkumba University, there and then it tells you. Okay? How does it get those correct answers? And how does it consider? Because when you tell me about Nkumba University, it's going to tell you. After 5 seconds, again, if another says, tell me about Nkumba University, it is going to tell him another story. It's going to give the person different words. Why does it give the same words? Okay. On top of that, you do that discussion question, which is on the screen. Each group, you do it. Okay, we can call it a day. For the distance students, you can do it on your own because there's no way you can meet. But if you think you can meet, you can form a group. Is Kaka online? Kaka?
Sir, are we going to be having online classes throughout, or we'll have some days where we'll meet physically?
Some days we shall meet physically. But why do I want these online classes? I want the distance students to get something out of it. Yeah? Because the physical classes, the distance students will not be able to meet. But
Okay, sir.
sometimes we shall have the physical classes. Especially when I come to, I don't know for the distance, but when I come to reasoning techniques, those ones I would prefer teaching them physical because that is a crucial topic, reasoning techniques. I prefer teaching them physical. Okay? Any other? Silence means people have understood everything. I wish you another nice day. Someone has another question here. How about the previous assignment you gave us? Also do it, people. We came to study. I can give 100 assignments. The more assignments you get, the more you understand these things. Because every assignment is teaching you something. So don't worry about your previous assignment. Do the previous, do this one as well. One time I will tell you, start presenting the assignments. So for your job is to do the assignments as they come. Okay, I think we can say we can have a nice day. If nothing else.
Thank you, sir.